Hello everyone, welcome back to Prestige Academy's online subject courses. This is Algebra 1, Class 9. Today we're going to be going over compound inequalities. We will look at and or questions and absolute value. Lastly, we're going to solve a word problem based on these concepts. Now, before we get into all of this, there is a short introduction. Compound inequalities means two inequalities joined by an and or an or. And with this comes two facts. Compound inequalities using the word and are true only if both inequalities are true. Compound inequalities using the word or are true if one or both inequalities are true. All right, now let's get into the and or questions. These are going to be things we use the number line to answer. And just to review, greater than or less than are represented by an open dot on the number line, and greater than or equal to and less than or equal to are represented by a closed dot. All right, now let's get into and first. With a compound inequality using and, there's going to be an inequality here, going to be and another inequality. Now, if we see something like this, we know that both dots are going to be open. Let's give an example. X is greater than 5, X is less than 7. And if we can draw the number line here, what we do first is we find 5 and 7 on the number line. Let's say this is 0, 1, 2, 3, 4, 5. 5 is going to be an open circle because it's greater than. 6, 7. 7 is also going to be an open circle because of the less than. And to just combine these two inequalities, just draw a line between them. So our answer is, for x is greater than 5 and x is less than 7, it's going to be like this. And that's 5 and that's 7. So when we're doing and questions, there are going to be closed segments on the line like this. Now let's do an or question. With or, again, there's going to be an inequality here, or another inequality here. With inequalities with or, the answer is either going to be two lines facing opposite of each other, like this, or two lines that intersect at some point. For example, one can be like this, and the other can be like this. Let's say x is greater than or equal to 5, or x is less than or equal to 3. We start by putting in the number line and finding the numbers. If this is 0, 1, 2, 3, 4, 5, greater than or equal to 5 is going to be 1, 2, 3, 4, 5. Now that is going to be closed. X is less than or equal to 3. 3 and less than or equal to is going to be 1, 2, 3 right here, and also closed circle. All right, x is greater than or equal to 5. If we were graphing this without the or and the second inequality, we would just make our closed dot and draw a line like this. That's exactly how we start with the or question too. And then we look at the second inequality and draw it like it doesn't have any of this. You would just circle 3 and draw less than. So with an or question, this is going to be our answer. This is how it looks like. There's going to be a line, an inequality right here, and an inequality right here. And what this means is our answer is either going to be over here or over here, but it can't be anything in between these two numbers. Let's start with an example of an or question. Again, we're going to put our number line in. And if this is 0, it'll be 1, 2, 3, 4, 5, 6. First, let's start by graphing x is less than 3. Because it's not less than or equal to, and it's just less than, we're going to start in an open circle. And because it's less than, we're going to draw a line towards the left. And for x is greater than 6, again, an open line. And because it's greater, we're going to draw a line towards the right. So basically what this means is the answer for x is less than 3 or x is greater than 6 is anywhere on this number line where there is a line going through it. So everything to the left of 3 is an answer, and everything to the right of 6 is an answer. But any number between 3 and 6 cannot be the answer. So 2 is an appropriate answer, and 7 is, but for example, 4 is not an answer to this question. Another example we have is with and, same numbers. You put the number line in. And this is going to be an important question because we're going to be using the facts we learned in the previous slides. Okay, let's start by putting 0 in. 0, 1, 2, 3, 4, 5, 6. X is less than 3, again, open circle, line to the left. X is greater than 6, open circle, greater than. If you remember the facts, we said that when there was an or question, one or both needed to be true. But when we had an and question, both inequalities had to be true for something to be the answer. What that means is, for and questions, we're looking for something to overlap. If you can see in the number line, this line goes this way forever, and this line goes this way forever. They never intersect. They never overlap anywhere on this number line. That means this can't be the answer because it doesn't satisfy x is less than 3, and any of this cannot be the answer because they don't satisfy x is greater than 6. Between these two lines, it doesn't satisfy either of the inequalities. What that means is this does not have an answer. There is no number that is less than 3 but greater than 6. And questions, they need to overlap. And where they overlap is the answer. And for or questions, they don't need to overlap. They can go that way, or they can just be something like this. Now, sometimes you're going to see compound inequalities represented that way. And what this means is basically 5 greater than or equal to x, and x greater than 8. You can separate them like this and put an and in between. And this is going to mean the same thing as this. So, let's draw a number line. 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 is greater than 8, our line. 5 is greater than or equal to x is going to be x is less than or equal to 5. They're the same thing. 1, 2, 3, 4, 5. In this case, it's a closed circle because of the equal to, and it's less, so it's going this way. And as you can see, they don't overlap. So our answer for this question, if it asked for an x that worked, would be that there is no x on the number line where 5 is greater than or equal to x and x is greater than or equal to 8. So this would be no answer. Our next example is going to be an or question that has a little different answer. We again start with the number line. Let's make this -2, -1, 0, 1, 2, 3, 4. X is less than 4 is going to be an open circle of 4 and less than. X is greater than 0 is going to be starting at 0, an open circle, greater than. Now, if this was an AND question, we would just take whatever is in the middle, whatever point both of these inequalities are overlapping in. But because this is an OR question, we have to consider all of this, even the points where only one of the inequalities is true. So the answer for this question would be all real numbers, because these two inequalities cover everything on the number line, whether it's just one of them or both of them together. In some cases, OR compound inequalities intersect, but the answer is not all real numbers. For example, if we have x is less than 3 or x is less than 7, we can draw the number line to 0, 1, 2, 3, 4, 5, 6, 7. X is less than 3 is going to be at 0, 1, 2, 3, open circle, less than, and 7 is going to be 3, 4, 5, 6, 7, again, open circle, less than. In this case, there's a point they intersect and a point they don't intersect, and a point where none of these inequalities go at all. And in this case, the answer would be all real numbers that are less than 7. Because in less than 7, there's at least one inequality that covers the numbers. So our answer would just be x is less than 7. And lastly, something you need to know for inequalities is if we have OR, we can also represent this with the word union. So we would say, for example, x less than 7 in union with x is greater than 3. And that means the same thing as OR. And you can also represent with a symbol like this, like a U. And with the AND, it's the opposite. With an AND question, you can also represent it with a symbol like a downward U. Basically going to mean where they intersect, the intersection. All right, now let's do an AND question with the intersection, and I'm going to show you guys how to show the answer as a compound inequality. Let's say 1 is less than x and x is less than or equal to 3. Now let's put our number line in. If this is 0, this is 1, 2, 3. All right, 1 is less than x means the same thing as x is greater than 1. And if you just switch it, it's going to be easier to put it on the number line. We draw our open circle at 1 and draw a line going this way. And for x is less than or equal to 3, we have a closed circle at 3 and our line is going this way. Now, because this is an AND question, we're looking at where they intersect. And where they intersect is right here between 1 and 3. There are different ways we can write this. The first way we can write it is, we can say 1 is less than x, whatever number the solution is, and x is less than or equal to 3. So it can't be anything less than 1, because 1 is going to be less than x. And it can't be anything greater than 3, because x is going to be less than or equal to 3. And the other way we can represent this is with parentheses. When we have a less than symbol or a greater than symbol, we can represent that by a parentheses like this. And when we have a less than or equal to or greater than equal to symbol, we can represent it by a parentheses like this. So in this case, we have 1 and 3. 3 is, x is less than or equal to 3. So we would use this parentheses over here. And because 1 is just less than x, we would use this parentheses over here. So both of these can be ways to represent your answer. Since we went over representing with the parentheses, I also want to show you guys how to use those parentheses method in representing questions with or. Let's say we have x is less than -2 and x is greater than or equal to 5. The number line in. Let's say this is where -2 is, and this is where 5 is. Because this is less than, we would have an open circle going this way, and because this is greater than or equal to, we would have a full circle this way. And the way you would write your answer is, first, let's look at this part. This line is going to the left forever. So the answer is keep getting more negative. Like -5 is an answer, -6, -100. So the way we represent the end point of this line is with -infinity. And because it's -infinity and infinity is not really a number, we use this parentheses. Put a comma, the other side is -2, and because it's an open circle, again, we use the same parentheses. And then we put the in union with symbol. And the starting point for this part is 5. And because it's a closed circle, we are using this parentheses, the comma, and this side is going right forever. So in this case, again, we're going to use infinity, but we're not putting the negative sign in front because it's going positive. And again, because infinity is not really a real number, we close it off with this type of parentheses. So our answer is represented like this. There are a few rules we need to go over before we start doing questions. The first one is the most basic rule. This is what absolute value means with equalities. If we have a number inside the absolute value symbols, and that is equal to another number, then both of these expressions must be true. That number, whatever is in the absolute value, can be equal to this number or the opposite of that number. Now let's assign values to this so it's easier to understand. If we have x inside the absolute value symbols, and that's equal to 7, that means x can be equal to 7, this number, or -7. That is because if we have -7 inside of the absolute value, the negative cancels out and we get 7. So if we have absolute value of x plus 5 equals 6. In order to find x, we need to separate this into both of these expressions. So x plus 5 is equal to 6, and x plus 5 is equal to -6. And you need to solve for both of these in order to get all possible values of x. The second rule is with a less than symbol. If we have a number in between the absolute value symbols and it's less than c, -c is going to be less than whatever is inside the absolute value, and that's going to be less than whatever number this gives us. Let's use the same example to understand this better. If we have something like this, that's going to mean that -7, -c, is less than x, which is inside the absolute value, less than 7. And lastly, we have the greater than situation. If we have anything inside the absolute values and they're greater than a certain number, then we separate them again like the equal sign into 2, and whatever's inside the absolute values is going to be less than negative of c, or it's going to be greater than c. So if we have again something like this. We separate it into two. X is less than -7, or X is greater than 7. So the way you can remember this is with less than, we have an and situation. Imagine this as X. We have something less than X, less than something. And with greater than, we have an or situation. And all the rules with and or also apply to this absolute values. Now let's do some questions. Our first is going to be in equality to make it easier and get us into understanding the concept of absolute value. The rule with this was whatever is inside the absolute value is going to be equal to C, and we separate it into whatever is inside the absolute value equals -C, and whatever is inside the absolute value also equals C. All right, so this, following this rule, is going to be 2x plus 4 equals 7, and 2x plus 4 is equal to -7. And then we solve both of these. -4 on both sides. We need 2x equals 7 minus 4, which is 3. Both sides divided by 2. X is equal to 3 over 2. And the second one also is solved. -4 on each side. 2x is equal to -7 minus 4, which is -11. Divide both sides by 2. X is equal to -11 over 2. And with this absolute value and equality, that means the answer is both 3 over 2 and -11 over 2. Now we have a question with the inequality. The rule for greater than was with or. We separated it into two. Let's go back to that slide. The rule with the greater than was separating it into whatever's in the absolute value less than -3, I mean -C, or whatever's in the absolute value greater than C. Let's go back to our question. Inside the absolute value, we have 5x. So following that rule, we say less than -3, and 5x is greater than 3. And then again, we solve both of these. X is less than, divide both sides by 5, -3 over 5. And x is, divide again both sides by 5, 3 over 5. And as you remember, the rule with or was that one or both are going to be true. So our final answer would be both. X is less than -3 over 5, and that's supposed to be greater than, x is greater than 3 over 5. Now we have a less than question. With less than, as you remember, we followed the and rule. So if we go back to our rule slide, as you can see, with less than, we had whatever's in the absolute value, and it's going to be negative whatever it's equal to, less than the value, less than the C. So going back to our question, if we rewrite this with that rule, we're going to get -4 less than 3x plus 1 less than 4. And in order to solve that, you can do two different things. You can either separate that into two inequalities, one like this and the other like this, and solve both separately, or solve both of them together. Let's solve them both together to show you how you would do that. So whatever you do with this, you need to do on both sides. So imagine this as something like -2 is equal to x equal to y plus 2, for example. Whatever you do here, you would have to do also here. Let's start with getting rid of this one. We're going to do -1 on all three sides. So that's going to be -5 less than 3x less than 3. And then we're going to divide all of the sides by 3. -5 divided by 3 is going to be -5/3 less than x less than 1. So our answer is going to be this. And if we look at the number line, -5/3 is going to be somewhere around here if 0 is here and 1 is here. X is less than 1 is going to be shown like this, and -5/3 is less than x, meaning the same thing as x is greater than -5/3. It's going to be shown as this. So our answer is right where these two intersect, right here. And this is the answer. But there are going to be cases where the answer you get doesn't make sense. The answer you get is going to be something like this. And in that case, you're going to say there's no answer. There is no x value where this is true. So you have to go back and check your answer with the number line to make sure you actually have values that satisfy the expression. All right, now let's do a word problem that uses this concept of compound inequalities. A student has scores of 87, 81, and 74 on his first 3 tests. What score must he get on the 4th test to have an average of 85 or higher for the 4 tests? First, let's start by going over averages. We're going to make a separate video with averages, medians, and all of that stuff, but for now, let's think of the average as all of the values that added up. x1 plus x2 plus x3 plus x4, in this case we have 4 different tests, divided by the number of tests, which is 4. And that's how we would get the average. In this case, our first test is going to be 87, second is 81, third is 74, and we don't know the 4th test. So let's put that as x. And because our 4th test, we're going to be dividing it by 4. And we want the result to be 85 or higher. That means our answer is going to be higher or equal to 85. And then we can just solve this like we would solve any expression, any inequality. We multiply both sides by 4. 4 times 4 times 4. The first side is going to be, 4s are going to cross out, so 87 plus 81 plus 74 plus x is going to be left, and again, greater than or equal to. And then 85 times 5 and 85 times 4 is going to be 340. And then you can just add all of these numbers up. 87 plus 81 plus 74 is going to give us 242. 242 plus x greater than or equal to 340. And again, continue with the solving. Subtract 242 on both sides. So 340 minus 242 is going to give us 98. So if we write this over here, our final answer is going to be x is greater than or equal to 98. What 98 in this case means is that in order for this student who scored 87, 81, and 74 on his first 3 tests to get an average of 85 or higher. He needs to score a 98 on the last test. Alright, that's it for today. Thanks for watching. In the next lesson, we're going to go over mean, median, mode, and range, and we're going to have a set of numbers, and we're going to have to find all of these from the given units that the question gives us. Thanks for watching, and I'll see you guys in the next lesson.